this part here, now you're given this formula, so you can see this formula inside here, right? So split it apart. No need to think so much on. Split it apart. This is r equals to 1 r square, 3 square plus infinity r equals to 1 minus half r 3r. Okay. Now if this is infinity, basically your n goes to infinity here lah. For the first one, just use the formula given, right? It's given to you. Just use it. If you want to write it properly, it's just mn to infinity bracket 3 over 2 minus n square plus 3n. You cannot set infinity in the expression, just remember that. Like that. Okay. Then the subsequent part here, you can actually just I will suggest you group it like that. Okay. Then if you're confused with this, right, just list everything out. Just list it out. I'll show you later. This one here, quite straightforward. As n goes to infinity, what happened? N squared plus 3n plus 3 over 2 3n goes to 0. Okay, because some infinity are larger than the rest, 3n will go much, it will be so big that n squared cannot keep it up. Okay, you can key in calculator with a very big value, you will see. But I think your calculator may break down anyway, because it's too huge, 3n. Once done, we could do this as 3 over 2 minus 0. Then this case here, the one behind here, will just become a sum to infinity. So this is just minus half 1 plus minus third square all the way to the end of the world here. Okay, so this is just sum to infinity. Sum to infinity. This sum to infinity is okay, right? GGP. First term is negative third. R is negative 1/3. So just use the sum to infinity formula. Please. Okay, looking calculator. I'm not sure what you'll get, but probably get the answer. 5 over 4. 1 over 4. 1 over 4. So this is 5 over 4. Okay, that's what you get. Is it okay? Oh, then after that, the second part is change of base. That's what we're gonna do. For the second part, we are looking at show that this expression here is this. Okay, this expression here, you can clearly see that is actually a derivation from this equation, right? So you sub r as r minus 2. So most schools will do this way here, bottom up, but I'm going to do top bottom, but they're the same steps actually. Okay, so just follow me very carefully. Now the first thing is I'm gonna just try and change this to this. This inside here, this term here, look at the term, eyeball the term first. You make the term the same first. Anything else is irrelevant. Make the term, make it look the same. So this is 1r squared equals to 3n plus 3 to 3n. Okay, so what you do is you sub r as r minus 2, because if you sub r as r minus 2, naturally this will be this expression here. But don't forget, when you sub r as r minus 2, the r on top, any r, you see r, you sub. You don't sub n, n don't change. N and r different, okay? So you sub r as r minus 2. So just r minus 2, just change all the r out, okay? So this boundary here, remember to change. The top has to change as well. A lot of times students forget that need to change the top part. So r minus 2 equals to n. Of course, you can skip step. Okay, if you are very as usual, I'm not going to skip this step here because I know some of you may require more refresher. So this is minus 2. Now then, the one on the right hand side will remain the same because you don't touch any n. Okay, this is 3m. So this will be m plus 2. Then you require to do some changing of bases. change of base. Change of base, you also have to be good at it. Not good also have to be good. I know it's quite jalat, but try. 2, 3n. Okay, great. Now once this is done, let's look at the boundary. You need this to be n. The top boundary is the easiest to change. This is n. This is n plus 2. Okay. How do you change n plus 2 to n? You sub n as what? N. Yeah. You sub n as n minus 2. The n is the easiest to change. The bottom boundary is the hardest to change. Okay. The bottom boundary you need to consider the terms, but the top is the easier. So sub n as n minus 2. So when you sub this as n minus 2, it naturally becomes n. Can I skip step here? I'll just skip. So you just sub every n out. N, you all can know what is n, right? Just n. The r, leave it. Don't care about the r. Okay, this is what I'll do. Square plus 3 n minus 2. So you do it like an onion layer. You see, what I'll do is I do the term first. Then after that, I do the top boundary. Then after that, I move down to the bottom bound. This part here, once done, you need now I settled most of my bills. The top one done, the UR done. Now I need to use R4. R equals to 4, but I have R equals to 3. My goodness, how? So if you have 3, okay, I'm going to tell you, you need to minus off the third term. Okay? But if you cannot see, draw the number line. You have, this is 3 to n. Okay, but you want 4 to n. This is what you want. 4 to n is here, right? Okay, so what you need to minus off is the third term. Remember that. You need to minus off the third term. So don't get confused. Anything, if you're confused, draw the number line. I repeat, you have 3 to n now. This is what you have. Okay, what you have is this one. A lot of times in life, what you have is not enough. So what you need is 4 to n here. Okay, so maybe you have more than enough, so you need to subtract some trash in your life. So there's U3, you subtract it out. Not bad. I just inculcate some philosophy of life in it. Yeah, it's just smoking. So minus U3, R equals to 4, R minus 2 square, 3R minus 2. U3, just replace it inside here. This is a UR, right? U3 is there. Okay, this is U3. Can I just expand this? Plus 4 plus 3n minus 6 plus 3 over 3n minus 2 plus 1 minus U3. U3 is 3 minus 2 square over 3 minus 2. Yeah. In this is 1 or 1/3. 3 over 2 minus 1/3. Hopefully I get this. Oh, 7 over 6. Looks good. What do I want to change to? 3n minus 2. Oh, 3n minus 2. So it will be n Copy wrong, yeah, sorry, yeah. So I got P is 7, Q is 6, and what is 1? This one.